Okay, so we're talking about sine and cosine graphs. So if I was labeling my notes, that's what I would label it. Hopefully these words in the front give you a little bit of comfort because we've done this before. Stretching, compressing, and reflecting. We've done all of those things, which means we're going to be talking about transformations today. And by now, you all should be experts at those transformations. All right, so the first thing we're going to do is talk about just what the basic functions, those parent functions of sine and cosine look like. And we want to remember, they've kind of made a little point for us here in the book. The points around the unit circle have coordinates sine and cosine. Remember, sine is x and cosine is y. So the first thing I'm going to do just to get kind of a good picture of what's going on is go ahead and draw myself this first quadrant of the unit circle and label that. And just for practice, if you will try to see if you can remember the different parts of the unit circle. All right, so we're going to remember cosine is x, and so we're going to start at the top for cosine. So that's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and then 1. And then cosine goes the other way, starts at the bottom and counts up. So that's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and then at the very top, 1. All right, and I've color-coded those on purpose so that we can see how the different graphs relate to one another. All right, so notice that the graph paper looks a little bit different for sine, cosine, and tangent. We're going to be counting by some different things here. Notably, we're counting by pi's down here at the bottom. Each one of these tick marks says pi over 4. I'm going to be counting by, I'm going to put 1 right here just so that we can see what this looks like. Sine, cosine, and tangent end up creating these curved functions. And you can think about it like you're either plotting the points, or you can really just kind of think about it like how we say. So, for instance, we say that we start at the top for cosine. So I'm going to start up here. Now, I'm saying that because that point that I just graphed does not match what I just said. So really, 0 goes with 1. So that's why at 0, I'm making a point of 1. Up here at the top, we have, I wrote that wrong earlier, that's pi over 2. And at pi over 2, my value should be 0. Now think about it. If I keep going around this unit circle, my x values are going to match, but they're going to start getting negative. So that by the time I get over here to pi, my cosine value is going to be at -1. So I'm going to do that on my graph. And then it's going to come back to 0 down here at the bottom of the unit circle. All right, that's 3 pi over 2, and then go back up to 2 pi. So it's going to create this like curved looking line. It's not straight, it is most definitely curved. It's going to match on either side, so I'm going to make a few of those points. All right, and we'll connect those. And really the biggest thing, I don't even know if that looks right, but the biggest thing that I want you to see is that cosine, just like with the first quadrant, how cosine starts at the top, it's going to start at the top here. The other thing I want you to see is just this like basic shape in this first quadrant, and I'll zoom in so you can see that better. That basic shape is kind of makes like it starts at the top and ends at the top. You want to start and end in the same place because think about if you're going around the circle, you're going to start and end at the same place every time. So the same idea here. All right, so if we look at the sine function, the sine function is y. Remember, we start at the bottom. So sine's going to start at the bottom. Eventually, it's going to get up to 1, and that's going to happen when we get to pi over 2. It's going to come back down to 0, go to -1, and then come back to 2 pi. So the sine function looks like this. All right, and then it'll match on the other side. So what you need to remember about sine, just like with that first quadrant, sine's going to start at 0, and then it has to come full circle, so it's going to have to end at 0. Okay, so we just need to keep those two pictures in mind while we go through some of the transformations. All right, so just like with before, things that are on the outside, so these A values up here, outside, remember we're shaking our head up and down, those are going to be vertical stretches or compressions, and those are exactly what you think. Now, you probably need to make a little point in your notes that vertical stretches or compressions affect what we call amplitude, and that the standard amplitude is 1. So normally, right, the highest value we get to is 1 because our unit circle has a radius of 1, and the lowest value we get to is -1. In this instance, we may be changing that value, so it may go higher or lower. All right, that's on the outside. On the inside, so we've got this like 1 over b that they've shown us here. The inside is going to affect horizontal stretches and compressions, And that's what is going to be called the function's period. All right, and the normal period, so we're talking about like how far it takes to get all the way around the circle. If you think about that in radians, it normally takes 2 pi to get all the way around the circle. So that's like the standard period is 2 pi. And what we may be doing is changing that so that the circle is either smaller and our waves are kind of pushed together, compressed horizontally, or that the circle is larger so our wave is spread out horizontally. So let's look at an example that's already completed, and then we'll try like 1 or 2 on our own. All right, so this example at the bottom, first of all, we're talking about sine. So the first thing we want to know is when we're talking about sine, we're going to be starting at this 0, 0 down here. So remember, sine starts at the bottom, okay? The other thing that I want you to note, there's a 3 on the outside. That means we're talking about a vertical stretch. So notice that this time the graph goes from +3 to -3 instead of from +1 to -1 like we did just a minute ago. Okay, so that so far should be really simple. The last part might be a little bit trickier, all right? We're talking about a 2 on the inside. So a 2 on the inside, we know that's horizontal. Inside is opposite, so that 2 becomes 1/2. So now we're going to be doing a compression. Well, the regular period is 2 pi, but we're going to be multiplying that by 1/2, right? Because we just said we're going to compress it by 1/2. So that means the period now I have is just going to be pi, which means by the time we get to pi, we should have gotten full circle. That means I want this to start at 0 and end at pi instead of 2 pi. And if you look at the graph, it does. It starts at 0, and by the time it gets back to pi, it's already finished one wave, right? One period of the graph. And then the graph just repeats itself. It does that same kind of pattern over and over again. I'm just changing colors so you can see it's really the same set multiple times in a row. All right, let's try one together. All right, so here we have a sine function, which means I want to start at 0, right? I'm going to start at the bottom. If it helps you, we can just make like a little kind of look or graph that's what sine's going to look like. Start at the bottom and then end the same place, all right? So we're going to talk about our amplitude. This 1/2 means that's going to be a vertical stretch. It's not stretch, compression of 1/2. So that means the highest I'm ever going to go is 1/2, and the lowest I'm ever going to go is -1/2. So my graph is really going to be squished down. The other thing I want to note is this inside, this is a horizontal. I got to flip it, so 4 becomes 1/4, so this is a compression, which is going to be affecting the period. So originally the period is 2 pi, but I need to change that by a factor of 1/4. So this time my period is going to be pi over 2. That means I'm going to start at 0 and end at pi over 2. All right, so I know it's got to start here at 0, just said that, end at pi over 2, and I need to do this full kind of loop before I get back to that pi over 2. So if I do that, that means it must come back down through pi over 4 and match on the other side. All right, so there's what one period looks like, and then I can just do that same thing again. 1, 1, and then we'll do the same thing on the other side just to give us a more full picture of what it looks like. All right, let's try one that's cosine. Okay, so this one is cosine, which means we're going to be starting at the top. And there's a few things to note. First of all, my amplitude here is going to be 3. That means I'm going to be going from +3 to -3. And this is kind of a trick. So normally cosine starts at the top, comes down, and then ends at the top, right? But because I have this negative sign, I'm going to reflect that. So this one is actually going to flip, and I'm going to start at the bottom. It's kind of a weird one, but I wanted to show you an example that looks like this. The last thing I need to make a note of is this horizontal, either stretch or compression. So this horizontal, currently x over 2 means 1/2 x, just so you know that. All right, so that 1/2 is going to flip and become 2, and so that's going to be a stretch. That means we need to change the period, which is normally 2 pi. We're going to multiply that by 2. So now my period is going to be 4 pi. So that means I'm going to start at 0 and end at 4 pi. So we're going to do that here. Start at 0, or sorry, not start at 0, but well, yes, the period will start at 0, and end at 4 pi. So that means by the time I get back to 4 pi, I should be in a matching position. Okay, so this is going to turn upside down. This is a little bit weird. So we're going to go ahead and go through here. It's going to hit the peak halfway through, right? And then come back down. And then we can match that, we can continue that going. So let me just talk through that one more time. It starts at 0, right? And normally it would start at the top. Because this is negative, we're going to start at the bottom. And it needs to end in the same place it's starting, right? These need to be like equivalent spots where the period ends. So starting at 0 and ending at 4 pi. And then I know it's got to hit like its highest or lowest point on the other side of that. So just to make this look symmetrical, I made the highest point at 2 pi and traced through. And then I did the other thing the other way, coming back down. And then if we were just to continue this, right, it would just continue doing something symmetrical on the other side. This is very hard to draw quickly. All right, make sure you have those notes, and we will keep working on this together tomorrow.